In this video, we are going to be discussing section B of the sample question paper of 2024-2025. There is a playlist where I am having all the videos compiled in the same place, and after we finish solving all the sections, I'll make sure to upload a video that compiles all the sections into one. Also, definitely let me know if you found this video helpful, and if you have any questions related to any topic or a question itself, can be NCERT or a previous question, definitely let me know. So let's start with this. So this section contains 5 questions with an internal choice in one question. The following questions are very short answer type, and they carry 2 marks each. Now, the first question: nitrogen gas is soluble in water. At temperature 293 Kelvin, the value of KH is 76.48 kilobar. How the solubility of nitrogen vary at a temperature above 293 Kelvin if the value of KH rises to 88.8 kilobar. Now, based on this, first of all, we need to find out how will the solubility of the nitrogen change when you change the temperature. Okay, that's what we're trying to figure out. Now, the thing we've been given is the value of KH. That automatically implies that this question is related to Henry's law, and this is under the chapter solutions. So the value of KH has been given to us in 2 cases. It is 76.48 kilobar when the temperature is 293 Kelvin. Okay, and the value of KH has also been given as 88.8 kilobar at higher than 293 Kelvin. Now, the value of KH is the Henry's law constant, right? So, according to the Henry's law constant, different gases have different KH values at the same temperature. And also, so that means it's dependent on the nature of the gas. Also, the value of KH depends upon the temperature itself. Now, when you have a higher value of KH at a given pressure, the lower is the solubility of the gas in the liquid. So this implies that the value of KH, when it increases, the solubility is decreasing. So the solubility of nitrogen over here will decrease when you are increasing the temperature. So that's what is given in your solution, in the solution over here. So they've mentioned 2 important points, and each of them carry half a mark each, right? So solubility of a gas is inversely proportional to the value of Henry's law constant or Henry's constant. On increasing the temperature, nitrogen becomes less soluble because the value of KH goes up. So that's all. So as long as you have both these points included, you're good to go. The second question over here is chloroform boiling point 61.2 degrees Celsius and acetone boiling point 56 degrees Celsius are mixed to form a azeotrope or an azeotrope. The mole fraction of acetone in this mixture is 0.339. Predict the boiling point of the azeotrope formed, and we have to defend our answer. Now, from the word azeotrope, this is also from the chapter solutions, and this is specifically from the topic of non-ideal solutions. So under non-ideal solutions, we had learnt about 2 deviations from Raoult's law. You have a positive deviation and a negative deviation. Chloroform and acetone, this particular mixture, undergoes a negative deviation from Raoult's law. This is because the AB interactions, that is the interaction between chloroform and acetone, is much stronger because of the formation of a hydrogen bond or intermolecular hydrogen bond which is formed. Okay, so this in turn, what will happen is, leads to a negative deviation from the Raoult's law. Okay, now we also learned about azeotropes under this. So the solutions that show a large negative deviation from Raoult's law will form maximum boiling azeotropes at a specific composition. Because it is forming the maximum boiling azeotrope, right? This means, and because of the negative deviation from the Raoult's law, the boiling point will be 64.5. because of the strong interaction. So because the interactions are very strong, they are forming a negative deviation from Raoult's law. They're forming a maximum boiling azeotrope. So their boiling point will be higher than the boiling point of the individual components. Okay, so that's why you have the answer over here. You will have to include the fact that you think the answer is 64.5. And why do you think that? It's because of the negative deviation from Raoult's law. So you need to include that point. And you also need to include that it's forming a maximum boiling azeotrope. And so the boiling point which is obtained will have the higher will be higher than that of the individual component. So you need to include all these points. So that's 17, question number 17. The question has an internal choice. So the second part of the question, a soda bottle will go flat or lose its fizz faster in Srinagar than in Delhi. Is this statement correct? Why or why not? So again, this question is based on the chapter solutions. Right, so this is okay. So this is basically under the concept of Henry's law. At higher altitudes, the partial pressure of oxygen is less, and because of that, you have people have to take additional. Climbers actually have to have additional oxygen tanks and stuff. This will help them minimize the symptoms called as anoxia. So what we care about over here is that at higher altitudes, partial pressure is less than that of oxygen at the ground level. So this automatically implies at higher altitudes, even for carbon dioxide, the partial pressure will be less than that in the ground level, and this will lead to a decrease in concentration. And because of this decrease in concentration, you have it losing fizz faster at higher altitudes. So that's what it says over here. At higher altitudes, the atmospheric pressure is lower. Solubility is directly proportional to partial pressure over the solution. So carbon dioxide will be dissolved lesser in Srinagar, making the soda go flat faster. So this is related to the concept of Henry's law. How does sugar help in increasing the shelf life of the product? Now this is related to the concept of osmosis. So this actually has been given in your textbook under the concept of osmosis. So the preservation of meat by salting and of fruits by adding sugar protects against bacterial action. This is through the process of osmosis, and the bacterium on the salted meat or candied fruit loses water, shrivels and dies. And that's exactly word to word is what has been written over here in the solutions or the marking scheme given in your given in the CBSE website. So basically question 17 was related to the chapter solutions. Question number 18. Write the IUPAC name of the following complex. KrCr H2O twice, Cr2O4, C2O4 H2O. Okay, I shouldn't even have bothered reading it. What we're going to do is, so this is obviously from the chapter coordination chemistry. And let's first write down our question. So K potassium Cr H2O twice, right? And then you have C2O4 twice. I guess I can scroll to this side. And then you have H2O. Right, so this is the question. So first of all, the cation is named first, right? So that is going to be potassium. The next one are going to be our ligands. So the ligands over here, you have water, which is going to be called aqua. And then you have C2O4, which is the oxalato. Okay, and you have two of them, so we are going to have to include the word di. Right. Now, you have oxalato for this, and this is going to be in the alphabetical order because water is aqua. This obviously is going to come first. Now, the central metal, which is chromium, it has to end with 8, so it is going to be chromate. Right. Now, we need to have the oxidation state of the chromate or of our central atom. So that is going to be 1 plus X plus 2 into 0 plus 2 into minus 2, because aqua or water is a neutral one and oxalate is a negative negative ligand. Oh my god, negative ligand. So it's going to be, so its total is going to be equal to 0. So x plus 1 minus 4 equals 0. X is going to be equal to 3. So this is the oxidation state of our chromate, right? So the name of this particular complex is going to be potassium, POTT. Oh, I apologize for spelling potassium so incorrectly over here. So you have potassium, and then you have your ligands. So diaqua, dioxalato, chromate, 3 hydrate. That is the H2O over here. So that's the name. And if you, and this is obviously from the chapter coordinate chemistry or coordination compounds. And it's under the naming of mononuclear coordination compounds. So basically we started with the potassium, which is the cation. And then we moved on to the anion. Under the anion, you have two ligands, diaqua, dioxalato, and then chromate. And then we calculated the oxidation state of the chromate, and then we were able to find out the name or write the name. So the next question, name the metal present in the complex compound of hemoglobin and vitamin B12. So this is under important compounds related to, or important importance and applications of coordination compounds. One of them is about the importance of the coordination compounds in biological systems. So you have hemoglobin, which is a compound of iron. So iron is going to be the metal present. So this is Fe. And for B12, cyanocobalamin, the coordination compound of cobalt. So CO. CO. Okay. The next question. Okay, this question has been one of the very difficult ones to answer, and I have not been able to find a valid reason for me to be okay with this. The only thing, okay, let's first of all, question number 19. Observe the following cell and answer the questions below. So we've been given this cell and we need to answer these questions, right? Now, the first question is represent the cell shown in the figure. So for the representation of a particular cell, we need to figure out what the what the anode, cathode, and the Sol bridge are. Okay, now my issue with this is that we've not been given the direction of the current. And that's fine, we can try and figure it out. However, when you look at the answer over here, it implies that this particular, okay, so usually we will have our anode on the left, and then you will have the cathode on the right. So we need to figure out our cathode and anode. Okay, according to the answer given to you in your marking scheme, according to this, it seems that the anode for this is this electrode. Y is the anode and X is the cathode. The only reason I could find for this to be the case is that this actually has a minus sign over here. So maybe that's why this is considered to be the cathode. However, I couldn't find a valid justification to be okay with this particular answer. So according to your CBSE syllabus or according to your CBSE marking scheme, it says that this Y is the cathode and X is the anode. Okay, but according to a normal representation of a Daniell cell or an electrochemical cell, what over here you have is you have the anode on the right and the cathode on the left. Okay, now based on this, the answer actually has to be that X is the anode and Y is the cathode. Okay. And also definitely let me know if you have a valid reason as to why you think what's given in the CBSE textbook is right. I couldn't find anything, which is why I think both of them might be right. I don't know. I'm not sure. So definitely let me know. You can add it in the comments below. But basically, always remember when you have electrochemical cell X or for the representation, you're going to have anode and then you have the salt bridge and then you have the cathode. And that's how this has been represented as well. Okay, now the next question is where is it? Name the carriers of current in the salt bridge. So the carriers of the current in the salt bridge. Actually, this particular concept has been discussed in chapter called redox reactions in class 11. So that's where I was able to find this. So basically you have the migration of ions through the salt bridge is how the electricity is going from one beaker to the next. So the carriers of current are going to be the ions. The last question is write the reaction taking place at the anode. According to the CBSE, the marking scheme, Y is the anode. So Y gives rise to Y2 plus 2 electrons. In my opinion, I don't think that Y is the anode. So I'm just going to say X gives rise to X plus an electron. Oh, solid. I'm sorry. So again, if you have a valid reason as to why, I did try to look for galvanometers and try and figure out what it is from there, but I could not. Again, if you have any sort of idea, definitely let me know. I'll be more than happy to have an edit added to the channel for this. Okay, the next question is for visually challenged learners. You have magnesium Mg2 plus, Ag plus and Ag. We need to identify the cathode and the anode. And I just told you that when you have a representation like this, you're going to have anode on the left and cathode on the right. So the anode is going to be magnesium, which is on the left, and cathode is the silver. And we need to write the overall reaction. So Mg plus 2Ag plus gives rise to Mg2 plus 2Ag. Obviously, you'll have to balance out the equation. I can just write that really quickly over here. So you have Mg giving rise to Mg2 plus 2 electrons. Ag plus gives rise to Ag. Ag plus an electron gives rise to. So you have to have 2 and 2. And so you'll be getting Mg plus 2Ag plus gives rise to Mg2 plus 2Ag. And the two electrons can get cancelled. So that's why you have this as the answer for this question. And this is from the chapter electrochemistry. Question number 20. Complete the following reaction by writing the major and minor product in each case. So you can pick any two of this and then you can just write the answer. Now I'm just going to discuss all of them, obviously. So based on the look of this, it seems like all of these are from the chapter of haloalkanes and haloarenes. So the first one is reaction with KCN. This is a nucleophilic substitution reaction, and for reaction with KCN, you have the ability of formation of C attachment of the bond formed between the CH2 and C or NC. Both are possible, but for KCN, it's going to be the RCN, that is the cyanide, that is the major product. Okay, or nitrile, which is a major product. So the answer is going to be CH3, CH2, CN. This is the major product. The minor product will be CH3, CH2, NC. So that's going to be the minor product. The next question is, it's an alkene reacting with HBr. So this is related to the concept of Markov-Nikov's rule. According to Markov-Nikov's rule, the halide component bonds preferentially with the higher substituted carbon, whereas the hydrogen prefers the carbon which contains more hydrogens. So this makes, I'm going to just write the answer to this question over here. So the major product for this would be CH3, CH2, CH, CH3, Br, and the minor product is going to be CH3, CH2, which is bromobutane. So the minor product is going to be halide attached to the carbon with more number of hydrogens. Major product is going to be halogen attached to the carbon which has less number of hydrogens or hydrogen atoms. So this is under the concept of preparation of halogen or alkyl halides, and specifically through the process or using the alkenes. The last question for this is, you have this is reacting with alcoholic KOH. Now, alcoholic KOH implies that it's undergoing the process of elimination reaction. Elimination reactions of alkyl halides leads to the formation of alkenes. Now, when it undergoes elimination reactions, there are two possibilities, right? So when you have, let me write the structure to this question right here. Okay. So you have CH3, C, because you have CH, right? So CH, and this is bonded to two methyl groups, CH, and then you have CH. Oh, sorry. I am sorry. Okay. CH and then Cl, and then you have CH3. So this can undergo elimination reaction, right? So the Cl is going to get kicked out from this carbon, obviously. The question is, does it form a double bond with this one or this one? And this is based on the Seitz's rule. According to Seitz's rule, the major product is the alkene which has greater number of alkyl groups attached to it. So let's write down our products. Let's write down both our products first. So CH3, C, CH3, double bond, C, H, CH3. Okay, plus it gets kicked out from this carbon atom. So that's going to be CH3, C, CH3, okay. CH3, and then you have CH and double bond CH2. So between these two, this is obviously the more substituted double bond. That is, you have more alkyl groups attached. So that's why this is going to be the major product and this is going to be the minor product. This is under the concept of elimination reactions. After we learn all about the SN1 and SN2 processes, the next reaction you learn about is elimination. So based on Seitz's rule, you are deciding which one is going to be the major and which one's going to be the minor product for this reaction. The last question under this section is the presence of, is question number 21. The presence of carbonyl group in glucose is confirmed by its reaction with hydroxylamine. Identify the type of carbonyl group present and its position. Give the chemical reaction to support your answer. So obviously this question is from the chapter biomolecules. Now, according to the, this is what I got, this is again directly from your textbook. I was able to obtain it from the structure of glucose. So glucose gets oxidized to 6-carbon carboxylic acid, gluconic acid on reaction with mild oxidizing agent like bromine water. This indicates that the carbonyl group which is present is a aldehydic group. So the answer given in your in the marking scheme is the carbonyl group present in glucose is aldehyde and the C1 and at the C1 atom. So glucose gets oxidized to 6 carbon carboxylic acid, gluconic acid with COH group at the C1 on reaction with the mild oxidizing agent like bromine water. This indicates that carbonyl group is present as an aldehydic group. And you can also possibly include the reaction as well if you'd like. And if you just mention the name, that's amazing. So with that, we're done with section B. In the next video, we are going to talk about section C. And I hope you found this video helpful.